Good morning, everyone, and welcome to today's presentation. I'm Dr. S.K. Singh, and I'm excited to share insights on a crucial aspect of contamination control. Today, we'll be exploring the source of contamination, with a special focus on cross-contamination via process tools. Over the next few slides, we'll look at how process tools can inadvertently introduce contaminants and what steps you can take to prevent this. So, let's get started and delve into this important topic. Let's start by understanding what contamination really means. Essentially, contamination is the presence of unwanted substances in a product. These can be anything that shouldn't be there and could potentially affect the safety or quality of what we're producing. There are different types of contamination to be aware of. Physical contamination includes things like dust or metal particles that can accidentally get into products. Chemical contamination involves cleaning agents or lubricants that might inadvertently mix into the product. And microbiological contamination refers to bacteria or fungi, which are microscopic but can have significant impacts. Now, from a regulatory perspective, the goal is clear. We aim for zero impact on product safety and quality. Even the smallest contamination can be problematic, so strict standards are in place. Let's talk about the key risk factors that can contribute to contamination. Shared equipment, especially in multi-product facilities, is a common concern because residues from one product can transfer to another if not properly cleaned. Poor equipment design, such as dead legs or rough surfaces, can trap contaminants and make cleaning difficult. Inadequate cleaning validation is another critical factor. If we don't thoroughly verify our cleaning processes, contaminants can persist. Improper maintenance of equipment can also lead to contamination issues, as worn or damaged parts might harbor bacteria or other unwanted substances. Lastly, open handling processes increase the risk of introducing contaminants from the environment or personnel. Understanding these factors helps us identify where contamination risks are highest and how we can implement better controls to ensure our products remain safe and of high quality. Let's take a closer look at the mechanisms of cross-contamination via tools. One key way this happens is through residue carryover, which means leftovers from a previous batch can remain on equipment and then get transferred to the next batch. Inadequate cleaning or sanitation is another major factor. If tools and equipment aren't properly cleaned, residues and contaminants can persist. Equipment wear, such as metal fragments from worn-out parts, can also introduce contaminants into the product. Additionally, leakage of lubricants or chemicals used in machinery can contaminate the product if not properly managed. Airborne contamination is another concern, especially during processing, where particles or microbes can become airborne and settle into the product. Now you might ask, what exactly is cross-contamination? It's essentially the transfer of contaminants from one source to another, be it from one batch to another, from equipment to product, or from the environment to the product. In the context of good manufacturing practices, or GMP, this is defined as the unintended transfer of materials or residues. And it's a significant concern for regulators like the FDA, EMA, and WHO, because it can directly impact product safety and quality. Understanding these mechanisms helps us appreciate the importance of strict controls and clean practices throughout manufacturing to prevent such contamination. Now, let's talk about process tools as a source of contamination. These include equipment like mixers, granulators, conveyors, filling machines, transfer lines, sampling tools, and utensils. You might wonder why these are so critical, so I'll explain. First, these tools come into direct contact with the product, which makes them a potential contamination point. Because they are reused across different batches or even different products, any contamination on these surfaces can easily transfer. Additionally, many of these tools have complex or hard-to-clean geometries, which can trap residues and make thorough cleaning challenging. All of these factors highlight why controlling contamination from process tools is essential to maintaining product safety and quality throughout production. Let's take a closer look at the regulatory expectations with a focus on GMP. One key point is the use of dedicated equipment for high-risk products. This helps prevent cross-contamination and ensures product safety. Additionally, validated cleaning procedures are essential. They confirm that equipment is cleaned thoroughly and consistently. Surface finish also plays a role. For example, a finish of 0.8 micrometers or better improves cleanability and reduces contamination risks. Controlling airborne contamination is another critical aspect, which is managed through properly designed HVAC systems. These systems help maintain a controlled environment and prevent particles or microbes from entering the production space. Moreover, having a documented contamination control strategy, or CCS, is vital. It shows that your team has a clear plan to manage contamination risks proactively. Now, when we talk about the regulatory framework, GMP is the cornerstone, setting the standards for manufacturing quality. HACCP is also important, especially for hazard analysis and critical control points, to identify and control potential hazards. For food products, compliance with FDA regulations like 21 CFR and FSMA is necessary. Most importantly, these regulations emphasize that equipment must be cleanable and properly maintained. Sanitation procedures need to be documented meticulously, ensuring consistency and accountability. And finally, preventing contamination from equipment and utensils is fundamental. It's about implementing practices that keep the entire process safe and compliant. All these points connect back to our goal of producing safe, high-quality products through rigorous control and adherence to regulatory standards. Let's take a look at the HACCP perspective on equipment-related hazards. First, it's crucial to identify any hazards that could be linked directly to the equipment we use. This might include residues, biofilms, or other contaminants that could compromise food safety. Once we've pinpointed these hazards, the next step is to establish critical control points, or CCPs, specifically focused on equipment. For example, a CCP could be the cleaning of a mixer before changing over to a new batch. At this point, defining the critical limit is essential. In this case, the critical limit might be that there should be no detectable residue left after cleaning. Monitoring these CCPs is vital. Regular checks ensure that cleaning and sanitation are effective. If we find that the critical limit isn't met, we must implement corrective actions immediately to prevent any risk. Overall, this approach helps us control hazards linked to our equipment, maintaining food safety throughout the process. It's about being proactive and thorough, ensuring every step is monitored and managed properly. Let's walk through a case scenario to see how critical proper cleaning is in our processes. Here, we have a shared granulator used for different products. In this instance, product A, which is an antibiotic, was processed, but unfortunately, inadequate cleaning was performed afterward. As a result, product B, which is a different product, became contaminated. This contamination led to the rejection of that batch. The impact of this kind of oversight can be quite serious. It can lead to a product recall, which is costly and damaging to the company's reputation. There's also the risk of regulatory warnings or sanctions, which can further harm the business. And of course, the financial loss from discarded batches, reprocessing, and potential legal issues is significant. This scenario highlights the importance of strict cleaning procedures, especially when sharing equipment between different products. It underscores how lapses in cleaning not only affect product quality, but can have far-reaching consequences for compliance and profitability. This aligns directly with our overall theme of maintaining high standards for quality and safety in manufacturing. Let's now look at monitoring and verification, which are critical components of ensuring product quality and safety. Swab testing, for example, involves analyzing residues on surfaces to detect any potential contamination. Similarly, TOC, or total organic carbon testing, helps us measure organic residues that could indicate cleaning issues. Visual inspection also plays a vital role, allowing us to identify any visible residues or defects on equipment and surfaces. Environmental monitoring is another key aspect. It involves checking the surrounding environment to prevent contamination risks. It's important to note that regulatory requirements often mandate periodic revalidation of cleaning processes, especially based on risk assessments, to ensure ongoing effectiveness. Moving on to preventive measures, equipment design is fundamental. We aim for smooth surfaces and eliminate dead zones where residues could hide. When it comes to cleaning, implementing CIP or SIP systems, clean in place and sterilize in place, helps us maintain consistency and thoroughness. Validated cleaning protocols are essential to confirm that our cleaning processes reliably remove contaminants. Segregation also plays a crucial role. Using dedicated equipment or organizing campaign-based production helps prevent cross-contamination. By combining these monitoring, verification, and preventive measures, we create a robust system that supports the integrity of our products and compliance with regulatory standards. Let's now look at some best practices to ensure effective contamination control. First, implementing a contamination control strategy, or CCS, is essential. This involves establishing a comprehensive plan that identifies potential contamination risks and outlines measures to prevent them. It's the foundation for maintaining a safe and compliant environment. Next, training personnel regularly is crucial. Well-trained staff are our first line of defense. They need to understand contamination risks and proper procedures to minimize those risks in their daily work. Ongoing education keeps everyone up to date with the latest standards and practices. Maintaining detailed equipment logs is another key point. Keeping accurate records helps us track equipment usage, cleaning, and maintenance history. This traceability is vital for identifying issues quickly and ensuring compliance with regulations. Speaking of maintenance, using preventive maintenance schedules is a proactive approach. Regular inspections and servicing prevent equipment failures that could lead to contamination, saving us time and resources in the long run. Finally, ensuring traceability and documentation across all processes creates a clear record trail. This not only supports compliance audits, but also helps us continuously improve our contamination control measures. All of these practices, when integrated, strengthen our overall strategy and help us maintain a high standard of quality and safety throughout our operations. In conclusion, I want to emphasize that process tools can be a significant source of contamination if not properly managed. They are often overlooked, but they play a crucial role in maintaining cleanliness and safety in our operations. Cross-contamination is a serious concern because it can compromise both safety and compliance, which are fundamental to our industry's integrity. Regulatory agencies prioritize prevention over detection, meaning our focus should be on implementing proactive measures to stop contamination before it happens. This is where strong GMP, good manufacturing practices, and HACCP, hazard analysis and critical control points, come into play. When these systems are well implemented, they provide us with the controls necessary to minimize risks effectively. Overall, the key takeaway is that prevention, backed by robust procedures and rigorous control measures, is our best strategy to ensure safety and compliance in our processes. For further support, please don't hesitate to reach out to us. We're here to help you with any questions or additional guidance you might need. Remember, you're not alone in this journey. If you found this presentation helpful, or if you need more information, feel free to contact us through the provided channels. Thank you so much for your time and attention today. We truly appreciate your engagement and look forward to supporting you further.